Good morning. My name is Manuel Amezquita. I am from EXI University of Bogota, Colombia. I will show you our project ID 66 influence of feeding channel and gauge geometry upon injected plastic parts using solid world plastics complement. This project is supported by the need of to establish the relationship between the shape and cross-sectional size of distribution channel and gates in the injection mold upon the quality of final injected pros. Experimental methods were conducted to detect the influence of the shape and size upon properties of final injected products like surface appearance and the presence of typical defects, well lines, air trapped, marked skins, hot pines, jetting effect, and other ones. The result shows that as shape as size are important in each one of the properties and characteristics of final product. The mold designer had to be careful to get the best possible results at the moment of select or take one or other design decision. General objective. Identify the relationship between the geometry and size distribution of channels and gate for or of an injection mold upon the final quality for a specific product using homopolymer polypropylene for injection processed through the SolidWorks plastics simulation and physical experiments. Specific objects. Select an injection mold that satisfy the experimental condition and objective of the study. Why? Because we need a mold, a multi-cavity that let us to study the filling conditions of each one of the cavity of the molds. Second, identify the influence of shade of the sectional crux of the channel on the final pressure on cavities. Third, simulate the injection process under different proposed geometries and compare with the practical experiments and quantify their effect in the presence of well lines, quality of filling, gas traps, and other defects. Methodology. The first stage of methodology is the selection of injection mold. The second, experimental test of injection process. The next one is the simulation with the SolidWorks simulation complement, then results analysis, and finally proposal of the best geometry and size for the channels. Mm, Materials and equipments. We used polypropylene homopolymer Polymax for injection mold that have a, a melt flow index of 30 grams in 10 minutes, a gel strength of 36 newtons by millimeter square millimeter, elongation of gel with a value of 28%, a iso-notched impact resistance of 28 joules by meter, and a hardness levels of 105. Head temperature deflection 100 degrees. The equipment uses were an injection molding machine Turbo 50 RS1, force clamp 50 tons, injection shot 36 grams of PS, band caliper 3 zones of 100 watts each one. We use also an extrusion plastometer according ASTM 12 and 38 Norman. This equipment was manufactured at the X University. Maximum temperature of operation 400 degrees. Third, analytical valence, Ohio's, for a multi-cavity injection molding of two plates that offer the best condition for this study. Experiments. The first stage of the experiment was to conduct the injection process of the parts. We decided and adjust the profile of temperature. We did the inject process, then determine the melt flow index at the laboratory to verify that this value reported by the technical data sheet. Um, Results of simulation. In figure number 3, we can see the sizes of the injected part and the condition of geometry of the actual mold using a circular or semicircular cross-sectional for the channels. In figure number 3, we can see the selected injection mold and the shape and size of the channels for this study. We consider a trapezoidal geometry, a modified trapezoidal geometry, circular geometry, semicircular geometry, hexagonal geometry, and finally a rectangular geometry with the indicated size. In figure number 5, we can see the air traps obtained for each geometry. We can see that the results are the trapezoidal geometry, that is the actual in the mold, circular geometry, and rectangular geometry. In table number 2, we can see different results for filling times, where we can see that semicircular geometry is the best value with 1.88 seconds. Pressure, final pressure, the offer was offered by trapezoidal, modified trapezoidal, with 8 megapascal at the end of the filling cavity. Temperature at the filling process, the best was the trapezoidal geometry with 220 degrees. Weld lines, number of weld lines, and temperature were the best results of was offered by semicircular geometry and trapezoidal geometry with one well lined at a temperature of 150 degrees. Air traps, the best results for air traps was with the trapezoidal geometry that offered 3 ultra points with a temperature of 50 degrees that they could be considered versatile because there are no possibilities of height high temperature points that can burn the injected plastic material. Conclusions. In simulation process, it is very important to consider the temperature profile in the barrel in order to get adjusted results in analysis of temperature in the cavity, the well lines effect, are directly related with the front flow temperature. Second, for this geometry, the best value of pressure at the end of filling is offered by modified trapezoidal sectional curve with a pressure value of 8 megapascal. This shape is often used in manufacturing process of injection mold. The lowest quantities of well lines and highest temperature values is offered by complete circular and trapezoidal cross section, one well line and 150 degrees. But complete circular shape configuration is not easy to manufacture. We have to to consider this in mind because uh, the cost of manufacturing is other important parameter. Fourth, the best results for air traps is offered by trapezoidal shape with three air traps at 50 degrees. That is a good value of temperature that prevent spots. That's all for now, and we hope that this presentation is the interest for all of the participants in this important event. Thanks in advance.